sine negative 9x cosine 8x dx. Sine cosine. So this one, we have to use the trigonometry product, and you have combined these two. So there are formulas you need to memorize. Sine alpha cosine beta equals half of sine alpha plus beta plus sine alpha minus beta. Like this is the formula you are going to use for this one. Okay, so is half of sine alpha plus beta, which is negative x, plus sine alpha minus beta, which is sine negative 17x dx. Okay, so then you use the formula, you use the antiderivative formula, is the half of antiderivative of cosine negative x, just cosine x. Antiderivative of sine 17 is cosine 17, but you have to divide by 17 because of chain rule. Okay, that's the number one. Number two, sine 3x sine 2x dx. Does it make sense, everyone? Do you want me to slow down? Because this is just a homework. You should know how to do it. Just review it real quick, right? Okay. So second one, sine x, sine 3x, sine 2x. We're going to use another formula. The formula is sine 3x, sine 2x, which equals half of cosine alpha minus beta minus cosine alpha plus beta. And then you have the formula, which is half of cosine x minus cosine 5x and dx. Use the antiderivative formula, so it's half of sine x minus sine 5x over 5. Does that make sense, everyone? Pretty simple, right? The only thing you have to do, if you know this formula, oh, I should not use 3x, it's half alpha and beta, because the formula is alpha and beta. Is you need to know this trigonometry function formulas. So number three, 0 to pi over 6, tangent x squared. Okay, before I do it, can anyone tell me what do you think? What do you do? How do you finish this one? How did you do this one yourself? This is a review, you should know it, because you did this one before.
Turn it into secant squared x minus 1.
Yes, perfect, yeah. 0 pi over 6 is secant, thank you very much. Secant squared minus 1 dx. The reason we do that, because the secant is derived, you can take the antiderivative of the secant square, which is give you directly the tangent x. This one is just the x. So from pi over 6 to 0, just plug in. Okay? And that's not a big problem anymore. Then next one, 0 to pi over 2, cosine t7 plus sine t dt. So can anyone tell me how you do this one? Okay, I'll do one more step. You have a sine t here, have a cosine t here. Whenever you see a trigonometry have something, you can substitute the other one. You always want to do that. So it's 0 to pi over 2. You can change the cosine t as d of sine t. Does it make sense? Okay. These two, combine them as 7 plus sine t. Now you can do the u substitution, right? U equals sine t. Or you just directly do that, it's fine. You can do u equals sine t is from 0 to 1, and du 7 plus u. This is much simpler if you try to do that. And just L and 7 plus u, plugging 1 and 0 into it. Does that make sense, everyone? Yes? Great. Okay. And Number 5. Negative 3 pi to positive 3 pi sine x squared plus 1 dx. Okay. So can you tell me how you do this one? If nobody tell me, I'm going to call a name. Randomly call a name because you all did this before. You want to make it bigger? Okay, so Zijian, could you please tell me? This is some problem. This is the problem you have finished before. Any of this problem could be on a test. For example, if this is just for example is a test problem, you have to know how to do it, right? So use power reduced formula, half of 1 minus cosine 2x plus 1. Then this one give you negative 3 pi to positive 3 pi. 1 half plus 2 is 3 halves minus cosine 2x over 2 dx. Then this is a 3 half of x minus antiderivative of cosine sine. So over 4. And plug 3 pi and negative 3 pi. And I think plug those both things 0. So just have this. If you plug 3 pi into here 0, plug negative 3 pi is 0. So it's 3 halves times 3 pi minus 3 halves times negative 3 pi. The other one, this one give you is 0 because sine pi is 0. So final answer is just a 3 pi. No, 9 pi. Yes? Okay. So next one, 100 plus x squared dx. And it asks you, what do you want the x to substitute as? This is a simple one. Anyone? X squared plus 100. Thea? 10 tangent theta. Perfect. Thank you very much. Because if you have 100, have kind of like 100 plus 10 tangent, and you have square is 1 plus, you got 1 plus tangent theta square, you can use that as secant theta square. Okay? This is just only ask you that. It's pretty good. The next one, 4 minus x squared to 3 half power dx. Okay? So x equals, I already told you x equals 2 sine theta. Okay, it tell you x equals 2 sine theta. What do we need to do? We just need to plug into the formula. So dx equals 2 cosine theta d theta. Okay, and then I plug it in. I would like a student to help me to finish this. Do I have any volunteer? If not, then I'm going to call a student to help me with it. Nicholas, could you please help me with this one?
Yeah.
Okay.
So it's 1 over, and then we can plug in 4 minus 2 sine theta, and then times 2 cosine theta d theta.
Yeah, that's very good. Okay, so we simplify this. I got, can you tell me what this is? You just don't want to work on Friday? That's why I choose Friday as a homework review class. Okay? But we still want to do some easy work. You have done all of this before. It's just review. It doesn't matter. It should be pretty simple for you now. 4 minus 4 sine theta squared, take a square root. It's 2 cosine theta. So 2 cosine theta cube is 8 cosine theta cube. And over 2 cosine theta d theta. So cosine theta cancel out, 2 cancel out is 4. And you have cosine theta squared. So basically I have 1 over 4 secant theta squared d theta. You know what I got? Make sense, everyone? Okay. So then I have 1 over 4. What's the integral of secant? Tangent, right? Alright, so next one, x squared square root of 36 minus x squared dx. It asks you x equals, it tells you x equals 6 sine theta. What we need to do, we just plug everything back into here. X dx equals 6 cosine d theta, right? You plug it in. So we got x squared is 36. Plug this back into here, 36 sine theta squared. Plug this back into the bottom is 6 cosine theta. Dx is 6 cosine theta, d theta. This will cancel out. So the answer is going to be 36 times sine theta squared, d theta. Then we use power reduced formula, 36 times half of 1 minus cosine 2 theta. So reduce is 18. Take the antiderivative of 18 is 18 theta. Take the antiderivative of 18 cosine theta is 18 sine 2 theta over 2. Plus c. Does that make sense, everyone? Am I done? Wait, I'm not done here, right? I have to put this one back into the x again. But you do that one yourself, okay? And this one, I'm not done yet. Even I got this is 9. Okay, so I got 18 theta plus 9. Wait, it's minus. Minus sine 2 theta. I have changed into 18 sine theta cosine theta plus c. So what you need to do, you find out what is, you convert the triangle into theta. So x equals sine theta. Sine theta equals x over 6. So this is 6. This is x, square root of 36 minus x squared. Then 18 theta. Theta equals x sine. So this is a theta. So the 18 arc sine x over 6 minus 18 x over 6. And the another one is another 6. Square root of 36 minus x squared plus c. Does that make sense, everyone? Okay. So how about now? I think I would like you to try to work on it instead of I'm working on this, because I can keep finishing that real quick. Okay, I finish everything with maybe 20 minutes. So now I would like you to work on the number 9. See if you can finish it out yourself, and they'll help you. Okay. Did you get the same thing? Or you can check your answer with mine. I sometimes make mistakes too. Okay. If I'm wrong, just let me know. You got the same thing? Yes, everyone? So first you got x equals 3 second. That's what it tells you. So 3 second. You take the derivative is 3 second tangent. And plug it in. You plug it in is first you got 3 tangent. Square root of that is 3 tangent. Okay, square root of x squared minus 9. And then plug in 3 secant, and 3 secant cancel out as 3 tangent. 3 tangent you change it into secant minus 1. So it's 3 tangent, you got 3 secant minus 3, and 3 tangent, and 3 theta. Then change the theta back into x. Did you get the same thing, everyone?
Should it be secant instead of sine?
Well, you can use any one. Here, theta. The reason I use sine inverse, you can use tangent inverse or secant inverse because it's just a representative of angle. Does that make sense?
Yep.
Yeah. The reason I use sine inverse because we use arc sine more, I believe. Okay, we use arc sine more. But you can use arc tangent. You can use arc secant. It's the same. We are talking about the same angle. Okay. Eventually, we only have x. Okay, we only have x here, so that's not a problem. We're talking about the same angle. If you use arc sine inverse, you have to use a sine function. If you use secant, use a secant function. You can change this one into 3 secant inverse of x over 3. This will be exactly the same thing. Okay. All right. So, other than this one, is everything else the same? Yes. Right? Okay. If I give you if the test, the problem test, problem like this kind of test, you will have one problem like this, okay? It's not hard, you just have trigonometry substitution, then put it back in, okay? So next one, wait. Okay. So next one, can you do that again? Give it a problem. Find the integral x equals 3 secant theta and x cubed square root of x squared minus 9. Can you try that yourself? Let me see. Okay. Do you got the same thing? Check your answer with mine.
I don't follow on the last step where you're replacing theta with x again.
So before this, everything is good, right?
Yes.
So up to here, everything is right. Okay. So last part, you got 243 times tangent. This is a theta. Tangent of theta is square root of x squared minus 9 over 3 to the 5th power over 5, right? Yes. And also, you need to plus 243 times 3 square root of x squared minus 9 over 3 to the 3rd power, right? Yes.
Yes.
Okay. Then what you got is 243. This is 3 to power 5. You cancel it out actually because 243 multiply that is on the top, right? You multiply that is 243 times 3 to power 5 square root of x squared minus 9 to power 5. Then this 3 to power 5, 3 to power 5, which is just 243. So this to cancel out, and then you have 5 remain. And then the top, you have 243 canceled with this. You got 81. Okay. Then 81 canceled with the 27. 3 to power 3 is 27. Square root of x squared minus 9. You cancel that is 3. So that's how you got x squared minus 9 to power 5 over 5 plus 3 square root of x squared minus 9 to cube. Does that make sense?
Yeah, I wasn't distributing the 243.
Yeah, I think that's how you. That's the final answer. Okay. If in the test you get the at least if you got this one right, I probably will mark off 2 points from here to here. Okay. Yeah, we will like have 2. It depends on how many points it has. Okay, like 20% from here to here. If you got it wrong. Okay. If you do if you just write like this, 243 the whole thing, 243 the whole thing. You don't simplify. I will just mark off 1 point. Okay. Let's see. Okay, where's the? Okay. So next one, I want to skip the 11. It's the same type of questions. Number 10, I think it's the same type of questions. So it'll be the same. Okay. Which one do you think is more you want to try and want me to explain? Now let's just go one by one. Number 11 is the same, right? Tangent and secant you can figure it out. Number 12, you can just assume x equals 9 sine theta. Okay. At top you're going to have a 9 cosine theta. So it's a simple one. Number 13, you assume x equals, you can factor out 64 first, okay? Then you got a 4 minus x squared, and x equals sine theta, 1 minus x squared, right? 1 minus sine theta squared. So x equals, you can factor, I'll give you a little bit help on this. Okay, 13 is x square root of 256 minus 64x squared dx. So what you do x factor 64 out. So it's 4 minus x squared dx. Then 64, you take it out, it's just the 8 in front of it. And I only have 4 minus x squared dx. So then I assume x equals sine theta. No, not sine, 2. And then I got 8, 2 sine theta, 2 cosine theta. Derivative sign is 2 cosine theta again. And then use this as a d of sine. Wait, no. since this is the cosine theta square, so I have to put that. You have 1, 2, 3. You have another 8 out again, so 64. And this 2 is the sine theta and cosine theta square d theta. I will put this inside this. So 64 cosine theta square d of cosine theta, but I have a negative. Okay, then this is u cube, u square over 2. This is u cube. So the answer is negative 64 cosine theta over 3 over 3 plus c. So change the theta back into x. That's it. Okay. Number 14, I believe is the same. Let me check if there's anything. Number 15. Okay. So does anyone need help with number 16?
Yes. Yeah.
Okay, so I think that's right. Okay, okay. So number 16 is find the area enclosed by this one, the area. Okay, so the area formula is from A to B, fx minus gx dx. So from this picture, can anyone tell me what the boundary is? If I do horizontal direction, what is my boundary?
Negative 5 to 5.
We don't have 5. I mean, negative A to A, right? I mean, this is the problem. There's no 5. Okay, just A B. So the right hand side is A, left hand side is A. So is I think you see this is the A. So it's negative A to positive A. Does that make sense? Okay. So next one. What is my fx? What is my gx? What is fx? What is gx? Anyone?
Fx will be the positive b over a, right?
Yeah.
And b negative.
Right. The gx is negative. Perfect. Okay. So what do you have? You are going to have negative b over a minus b over a, just 2b over a. 2b over a doesn't matter, just take it out. 2b over a. And negative a to positive a square root of a square minus x squared dx. Because b and a are constant, I just take it out. And then I just need to find the antiderivative of this one. So if you have the formula, it'll be much easier. If you don't have the formula, you still can figure it out, I think. Okay. 2b over a, what you need to do, let me make it bigger. Then you can copy that. Okay. So now our question is to find out what this is. Okay. So if you don't memorize the formula, just let x equals a sine theta. It does make sense, right? And then I have dx equals a cosine theta d theta. Okay. Now I want you to do this yourself again. Like work with me. You do on your own. I work on here, and then you can check with the answer. Okay. And it will help you to practice. The test for sure is going to be from your homework problems. Okay, you have to make sure you know how to do all of them. think you should about finish it. Okay, did you get the same thing, everyone? Yes. Okay. So none of the problems is really hard. It's just a normal process. Okay, I think this one is a very good problem as well. Okay, so you got square root of a squared minus x squared. Just do x equals a sine theta, dx is cosine, and just plug it in. Okay, when you do the antiderivative, whenever you see the constant, always take it in front. Okay, don't keep the a, b's in the antiderivatives or keep the numbers. You see the coefficient, for example, a and a here, always take it out. Put it in here, then it will simplify your integral a lot. Okay, so that's how you try when you do like an antiderivative, you see the coefficient, most likely you just take it out and cancel the a, you can take it out. It's just a cosine theta square. Power reduced formula, and take that, plug it in, you get the final answer is pi AB. Okay, so if you use the formula, you're going to have arcsine a over a, arcsine negative a over a, kind of like that. Here you basically got the pi over 2, negative pi over 2. It's not that time consuming because you don't have to put it back again. You don't have to put it back into x because you got the angle, just plug it in, so you got the final answer. So here, if a equals b, can anyone tell me if a equals b, what's the shape of this ellipse? If a equals b, what's the shape?
Circle.
It's a circle. Very good. It's a circle. If a equals b is a circle, then the area of the circle is pi equals pi times a squared or b squared, right? The circle of the radius is a or b because they're equal. So it's pi times a, which is pi r squared. You can tell that, right? So if a equals b is the area of the circle, that's how you got the circle formula. Alright, so next one, let's see. Number 17, partial fraction. Easy one, you can factor 40 into, you can factor 40 as 5 and 8. X plus 5, x plus 8. X plus 8 will be cancelled out. So just L and x plus 5. Number 18, you can factor this one. Number 19, you can factor it. Number 20, let me think. Okay. So number 20 or number 21, which one you think you need help?
Could you do 21?
Yeah, that's what I think. Number 21 is 0 to 1, x squared minus x, x squared minus plus x plus 1. It's kind of like a golden rule probably I've said in the class as well. Whenever you do the partial fraction, if the power are the same or greater, for example, if I get x cubed, whatever I have here divided by x squared, or x squared, if it's bigger than or equal to the power, you always want to divide first. Okay, you always want to divide first, because if they have the same power, or if the numerator has a bigger power, has a higher power, you always divide first. You want the numerator you have a less power. If it's x squared, you want to only have x. Okay, then you can do partial fraction later. So now what you need to do here, we divide it. X squared minus x, divide x squared plus x plus 1, and you can see this is x squared, this is x squared, so I use is 1. 1 times x squared is x squared, 1 times x is plus x, 1 times 1 is plus 1. Then I do subtraction, or you reverse, and you reverse all of them and then add them together. Okay, so this canceled out. Negative x, negative x, negative 2x, and negative 1. So I just divide it, and I got my answer 0 to 1, 1 minus plus. This is the remainder, negative 2x minus 1, x squared minus plus x plus 1 dx. Does it make sense, everyone? You divide it first, then I have a power which is less than this. So derivative of 1, antiderivative of 1 is x, plug 0, 1 is 1. Plus, well, I can do minus because both negative. 2x plus 1 x squared plus x plus 1, 0 to 1 dx. From here, anyone tell me what do you say from here? What do you say from here? Do you say anything special? Yes, you can do derivative of x squared plus x plus 1. And then the answer is 1 minus ln x squared plus x plus 1. Then you plug a 0 and 1 into it. So the answer is going to be just 1 minus, plug 1 into it, ln 3. Plug 0 into the ln 1, which is 0. So the final answer is just 1 minus ln 3. Does that make sense? So number 22, use the put a cosine as a dual derivative sign, put a negative in front. So you have d of sine x, you have the u equals sine x, you can do u substitution. This one you can put a secant x squared as d of tangent. So you have u over u times u plus 1. Okay. And number 24, you can do square root of x is the square root of x minus 4 times square root of x plus 4. Okay, you can do square root of x, or you can add the square root of x. You can add x equals sine theta, no, secant theta square. Okay, no, yeah, okay. So you can use the trigonometry integration for this. Number 25 is the partial fraction. Take the integer from 0 to 1. Okay. Number 25, just the partial fraction from 0 to 1 at 9 over x squared plus 9x plus 20 dx. And separate this two. Separate this one 0 to 1, x plus 5a and plus x plus 4b. And find ab, then you take that is the ln in the end. Okay. So that's how you finish the whole this is how the homework goes. If you have any question, just let me know. Okay.